Good afternoon, everyone. I'm glad you could join us for this AWC webinar, the 2018 International Building Code Essentials for Wood Construction, based on the code-conforming wood design document published jointly by ICC and AWC. I'm glad you've joined us. In case you aren't familiar with the American Wood Council, we are a trade association, represents about 80% of the engineered wood products and lumber producers in North America. We have three main divisions to our staff. The first is codes and standards, of which I'm a member. And then engineering, we have an excellent engineering staff. And then technology transfer, of which this presentation is also done by that staff as well. We are an ANSI accredited standards writing organization. Our engineering staff oversees our technical people from our members who work on the standards that are referenced in the building code for wood construction. A little background about myself. I started out many years ago as a building inspector and a plan reviewer for the city of Indianapolis and also the state of Indiana. I did some consulting and ended up on the code development staff of BOCA, Building Officials Code Administrators International, just before the turn of the millennium, when BOCA, SBCCI, and the IB and the Uniform Building Code, BOCA Building Code, the Southern Standard Building Code, were all becoming the international codes, the International Building Code. That's where I was immersed in codes. Along the way, I completed an engineering degree, became licensed and so forth. But my real strength is in the model codes, their development, and their application. I hope this is helpful to you today. This is, of course, you will receive credit through AIA, NCSES, and so forth, ICC. These are copyrighted materials. You've read this description, and I'll just say right now that trying to cover the entire International Building Code wood provisions in an hour and a half is, of course, impossible. It's a very broad course. Therefore, we'll move from topic to topic quickly and only treat the topics in a very broad manner. We'll talk about building size and parameters, structural provisions for particularly wood frame, special provisions for fire protection, and particularly the whole topic of fire resistance, and also non-structural use of wood across all the construction types. This presentation is based on this document called the 2018 Code Conforming Wood Design Document. It's available for download for free from our website, awc.org. It's co-published by the American Wood Council and the International Code Council, so you'll see their logo at the bottom. It's a broad brush index, you could say, to the International Building Code. The International Building Code being the code for commercial buildings, not 1- and 2-family dwellings. This document and the presentation today will not cover the IRC, the International Residential Code. It's going to focus on the IBC requirements. Although the IBC covers apartment buildings, hotels, and other residential uses, it's not for dwellings, detached 1- or 2-family dwellings or townhouses. These are the topics that the CWD covers in the form of providing an index to the building code. And we'll cover all these topics today, but they won't be in this order. I'm going to start out with fire resistance and construction types, and then we'll move through building size and other topics. Chapter 23 considerations will end up with precautions during construction. Just a word about, I told you a little bit about the American Wood Council. Let me say a word about ICC, the International Code Council. This is also a membership organization made up of code officials and fire officials. There is an industry membership category, however, it is non-voting. There are voting and non-voting members in ICC in regard to what goes in the codes. It's called a governmental consensus process, and only those responsible for enforcing the model codes published by ICC can vote on the content of those codes. Industry participates fully, of course, but we don't have a vote as to what goes in or doesn't go into the code. Another point about the I codes, they're not put together by a committee sitting in a room making sure all the research is done and all the code requirements are consistent with one another and written in a very coherent, smooth, consistent, and coordinated manner. ICC staff does an excellent job of taking what are essentially committee decisions about code requirements in the International Building Code and other codes. These are debated and discussed in an open format and voted on. So the documents themselves tend to be very, they're written by committee and therefore, and membership vote, and therefore they're not always coordinated. The provisions aren't with one another. They're not always completely sufficient, but they're the best we have. They focus on what you can't do rather than what you can do. But it may be helpful to you to remember how these codes are put together. And it's a wonderful process, a good process, and it's really results in a very excellent code. All right, we're going to have some poll questions. Here's the first one. Of course, there's no incorrect answer. Marcy?
Easy peasy. Let us know what your profession is. So we've got 65% engineers, 18% code officials, and a little bit of everybody else. And no matter your profession, we are delighted that you are here and welcome, and hope that you find something of value.
Great. Thank you, Marcy. As usual, we have mostly engineers. We're very, we're glad all of you are on, and we hope it's helpful today. Let's go right into types of construction. As we know, in the IBC, Chapter 6 is one of the primary chapters for describing types of construction. Wood frame is typically type 5, 4, or 3, and Chapter 6 also covers specific applications for types 1 and 2, which are traditionally non-combustible or specified as non-combustible construction. If you're following or you're leafing through the code conforming wood design document itself, it's in sections 5 and 6. Type 5 is wood frame construction primarily. It's any material permitted by the code. So you can have non-combustible building elements, of course, but type 5 has the smallest buildings. They're limited in height, area, dominated by wood frame construction, no doubt. Even in commercial these days, all your load-bearing and non-load-bearing structural elements can be wood or any material. Type 4 construction, I know this is review for most of you, but type 4 traditionally is heavy timber. So you have wood elements that are of a minimum dimension, posts and beams that make up the structural frame of the building can be classified as heavy timber. Fire retardant treated wood is permitted in certain locations such as exterior walls that would otherwise require non-combustible construction. Interior elements are all of wood, no concealed spaces. I mentioned minimum dimensions for type 4. We'll see that type 4 gets considerable building area and height as a construction type, and it's based on the inherent fire resistance and performance of heavy timber dimensioned elements. These are the minimum dimensions to qualify for heavy timber. And the flooring even must be 3 inches thick, 1 inch nominal dimension tongue and groove, or 4 inch thick cross laminated timber. I'll talk about that in a moment. Roof decking of a minimum thickness and so forth. You are permitted in type 4 to have a little bit of light frame in your partitions, as long as the partitions are rated for 1 hour. And so there's an exception there. Otherwise, all heavy timber dimensions. Type 3 construction is the next. This construction type is got a unique history. What are the defining features of type 3 construction? Well, the exterior walls, 2 hours, rated, and non-combustible. That's the same, by the way, for type 4 construction under table 601 when we get there. This construction type, I think it's significant to put this construction type in its context as being the inheritor, if you would, of old, what's called ordinary construction in many downtown areas across the country, where you had downtown buildings with masonry exterior walls between the buildings and at the building perimeters, and heavy timber or wood frame construction for the interior elements. It's important to remember this is where this construction type came from. It was describing a particular mode of construction that had performed well to add some boundary or fire resistance at the perimeter of the building, but otherwise was wood or heavy timber. The reason I'm pausing here about type 3 is we are going to talk a little bit about, actually, I'm sorry, let me stay there for a moment. We'll talk a little bit about exterior walls in type 3, our DCA 3 document. There are many questions about the function of the rating and the materials in the exterior wall of type 3. And if you have questions on that or any topic as we go about the seminar today, please go ahead and chat them through. We can maybe address some of them at the end, or we will address all the questions by email if necessary. But type 3, defining its wood construction, defining feature is the exterior walls are non-combustible or fire retardant treated wood, 2 hour rated. And then of course, the largest buildings permitted by the International Building Code are types 1 and 2. 1 is a highly rated, non-combustible, typically concrete or steel. Type 2 is non-combustible materials for the major building elements. May not be rated. Type 2B, for instance, is non-rated, but it is all non-combustible. Very important that we have, you know that section 603 has a list of 26 applications where combustible materials such as wood are permitted in even types 1 and 2 construction. Speaking of 603, across all the construction types, fire retardant treated wood is permitted in certain locations. Certainly, even in types 1 and 2, non-bearing partitions can be fire retardant treated wood, even in types 1 and 2 construction with some limitations. Non-bearing exterior walls can be fire retardant treated wood. Roof construction across the construction types can be fire retardant treated wood, except for certain type 1A buildings, balconies, porches, decks, and so forth. Probably most important, the last point here, exterior walls of types 1 and exterior walls of types 3 and 4 can also be fire retardant treated wood. Heavy timber has a unique place among the construction types, especially in roof construction. If you go to table 601 and look under the row for roof construction, you'll see a footnote C. Everything except type 1A, the largest, tallest buildings, can every other construction type can have heavy timber, a heavy timber roof structure. Among those, that list of 26 items in 603, there's many. I just pulled out on this slide interior finishes, millwork, trim, flooring, so forth, partitions, exterior. wall coverings, but you'll find the whole list in 603. Cross-laminated timber. Well, this has caused a sea change in regard to, this product has, in regard to wood construction, not only in regard to the, not only in regard to what you can do with wood, but also its structural performance, its fire performance, and finally, it has opened up a great expansion in the building code itself. In the 2021 edition of the International Building Code, there will be 3 new construction types that have been approved already for taller wood construction of heavy timber dimensions. And what has enabled this is this product called cross-laminated timber, which is dimension lumber or structural composite lumber laminated together in layers, as you see here, making solid wood floor and wall panels or roof panels. It's a different method, different performance, different code provisions. We have a tall wood page that will allow you to go to check out the studies that were overseen and researched by the International Code Council Tallwood Ad Hoc Committee. This is not the topic of our webinar today, except to say that in the 2015 IBC, cross-laminated timber was introduced directly into the text of the code, and you'll find it in the description for type 4. However, of course, it is permitted in type 3, 4, and 5 buildings for any elements. With one exception, I should say, that's type 3 exterior walls would not permit cross-laminated timber, but type 4 will. It does have to be protected, cross-laminated timber, with fire retardant treated wood or gypsum or a non-combustible covering in the exterior wall. But it got in the 2015, it's in the 2018 in the same manner. It has its own product standard, and there are test reports available. In addition to E119 and standardized test reports for fire resistance, there's not much non-standardized testing for compartment testing of full-scale structures using cross-laminated timber. So it's fascinating, it's new. There's a lot, because the new construction types coming in will be a lot to digest. We will be having, in conjunction and with the International Code Council's webinars on the new type 4 mass timber construction types. And there's a handbook, as you see here. So let's get right in it. I was talking about table 601. This is a primary location to define the construction types and to see what kind of fire resistance rating is required for each. I'm going to try to use this pen feature of my presenter capabilities here, and I just want to look at this. This is kind of unusual. We mentioned there are no ratings here except for exterior walls, which are 2 ratings, but otherwise heavy timber dimensions. This is the construction type category that will be expanded with the new tall mass timber construction types. Apart from that, you have type 5, 3, and so forth. The ratings are given here in this table. The basic structural elements. Now, there's a couple reasons why any building element might need to be rated. This is only one of them, to conform to the minimum fire resistance ratings for the construction type of the building, which is also the basis, of course, for the use and size of the building itself. When you establish fire resistance as a designer, or you're confirming it as a code official, it's important to know that the building code has methods that you can use other than individual testing of the elements that are used. In 703.2, you have a requirement for testing in accordance with ASTM E119 or 263. But if you go to 703.3, you have a number of other methods listed for establishing fire resistance that are based on those tests of assemblies or building elements. They're listed here. Mention a little bit about each. The testing itself for any particular building assembly, this is very common. Most of you are aware of this. You choose a tested assembly out of the fire resistance directory of one of the test laboratories, such as UL or the Gypsum Association. I think we're all familiar with that. You may also be familiar that the code specifically says you can use fire resistance designs from approved sources. Here's one of ours, American Wood Council DCA 3, designed for code acceptance, fire rated wood frame wall and floor ceiling assemblies. These are listings, you could call them generic listings of assemblies that are based on the body of test data for wood frame construction. I want to point out that I mentioned earlier that the, I'm sorry, trying to use the pen here, it's not working for me. Try it again here. Here we go. This document contains new details for wall floor intersections that will be very useful in type 3 construction. So just take note of that. We decided to put it into this document in response to many questions for how do you join a 1-hour floor to a 2-hour exterior wall in type 3B, for instance. That's a major question. There are practical ways to do it, and we have some details in here. So take a look. Among the other methods of obtaining fire resistance or establishing it is a calculation method. If you are using heavy timber and you have exposed beams or columns, there is a method to assign a fire resistance to those, even though they are not protected by non-combustible protection. They can achieve a rating. The principle is established in the NDS and referred to by the IBC. The principle here is you oversize the member so that it can burn for a certain period of time in the occasion of a fire and still perform its function. So you can quantify the fire resistance based on the size and the loading of the member, the extra wood that's provided, or in the case of this method, the that may be provided or other non-combustible material protection that may be provided for the member. If you want to know the formulas, the calculations, examples on how to do that, of course, in just our brief 1.5 hours today, I can't really go through an example, but good news for you is you have a whole free downloadable book from our website, Technical Report number 10. You can walk through examples of calculated fire resistance for exposed wood members there. Okay. Also, there's a well-known method, component additive method, for calculating, demonstrating assembly fire resistance. The calculated fire resistance for exposed wood members is mostly for elements such as heavy timber, but assemblies can also have an assumed fire resistance rating without individual testing of the assembly itself. The method is referenced in section 722.6 of the IBC, and this document, DCA 4, is the one that we point people to for the principles behind that method. In the code itself, you'll have tables such as 722.621, which would allow you to establish a 1-hour fire resistance rated wall, for instance, or floor. simply knowing the elements, the sizing, the spacing of the structural members, the thickness of the gypsum, and so forth. And you can easily establish a 1-hour element. If you need a 2-hour element, you can go to the NDS and use a method in Chapter 16 there. Among the other methods for determining fire resistance and engineering analysis, of course, the code allows this. Designers, engineers, and fire protection engineers also can use the principles in the NDS to compare designs between elements that have been tested or have an established fire resistance rating and make a judgment on fire resistance rating for elements and other elements that have not been tested. That's an option. I actually printed on this slide the actual code text. That's what we're looking at right now, because 703.3 is a very important section. And this is the way the code reads. 1, fire resistance design approved sources. 2, prescriptive ones from 721. Calculations for 722. Engineering analysis. And then to continue, alternative protection methods, that is, a code official would allow alternative materials and methods under 104.11, and fire resistance design certified by an approved agency. So there are multiple alternatives here. They are all based on a primary requirement for testing back in 703.2. Does not require that every element or assembly be individually tested. You have lots of resources here. All right. I know that was a very quick run through. Here's another poll questions. This should be a gimme.
Which of the following is an approved method to determine fire resistance? Is it tested fire assembly, ASTM E119 or UL 263? Or is it B, fire resistant designs documented in approved sources? C, prescriptive fire resistance rated assemblies elements in section 721? D, calculation of fire resistance per section 722, or E, all of the above? And all of the above, 96%. Is that right, Paul?
You got it. And I'm glad everybody got that right. If you didn't get that right, then you're not watching. But that's easy. But it emphasizes the point that there are many alternatives. So well done. All right. We'll talk about structural considerations, just give you a rough framework now for where to go in the code. What are the alternatives for structural design? First of all, know that reference standards are an integral part of the building code itself. So when you get to design, you may not have all you need in the building code in terms of parameters and design options. Well, that's why the code references certain standards such as the AWC National Design Specification for wood construction. They're all listed in the back. There's material standards as well as design standards. The addition does make a difference. If you're using the 2018 code, you've got the 2018 editions of the American Wood Council design standards. Here they are listed. We'll talk about these as we go forward. Most of you engineers are familiar with these, maybe not so much the wood frame construction manual. The special design provisions for wind and seismic has been developed to specifically address those elements of the building that resist wind, seismic, and other lateral loads. So, and what's happened now with, you had, for instance, shear wall capacity tables in the IBC in the past. They are now in the special design provisions for wind and seismic. Our own ANSI committees watch over the provisions for shear walls, for instance. So if you can't find what you need in the IBC, now you do go to, we call it the SPIDWIZ. Doesn't exactly fit the acronym, but close enough. Go there and find them. The IBC itself gives you some alternatives for design. Allowable stress design is most often used for wood. However, load and resistance factor design, our manuals, our standards, the NDS, as well as the IBC and so forth, itself are set up that you can use LRFD, the LRFD design methodology. It is fairly easily converted in the NDS. You might take a look at this one here and say, what is this conventional light frame construction? Well, this we need to be careful. We need to be careful with commercial buildings because this is one section in chapter 23, it's 2308, and it has a very limited scope for commercial buildings. And I'll discuss that, but we need to be careful there. The wood frame construction manual, that is a prescriptive document, mostly for 1 and 2 family dwellings. However, it does have some application to commercial buildings that fit within its scope. And then you have a standard for log construction. Just as an example of some of the chapter 23 provisions in 2304 and its subsections, you have some limits that'll be useful in design. The design of wood buildings commercially is almost always required by a registered design professional, but you do have some limits in this 2304 that are more prescriptive and some guidance in terms of, for instance, as an example here, wood structural panels, their application and their spans, maximum spans for roof application, walls, and so forth, based on for purposes of wind design. You'll find them there. So you can't neglect that section. Also, you will find some specialized sections that are more prescriptive. This one on lumber decking, 2304.9, you have prescriptive means to lay out and connect heavy timber decking or nail laminated timber floors would be found in this section. So this would be helpful in design if you're using large dimension lumber decking in your commercial buildings. Of course, there are provisions in chapter 23 on connectors and fasteners for wood construction. And there is a table, a fastener table. The table functions like this. Connections have to be designed to resist all loads. And the minimums for connecting structural elements would have to also meet table 2304.10.1. So you, as a designer, you're checking that table to make sure you meet the minimums. In some cases, you know the performance. For instance, if there's a connection, I serve lateral loads, but only gravity loads, and the range of floor loads and so forth, you use this table. But a reminder that all connections do need to be designed per the NDS. So the IBC doesn't contain all the provisions you may need. You do have a requirement in there for connecting, making sure there's a continuous load path as a design principle to take all the loads, the lateral loads especially, from the upper structure down to the foundation. And you have some provisions in there that would allow the use of manufactured components based on the manufacturer's instructions about them. And other miscellaneous provisions, these are just examples, such as fasteners that are used with pressure preserved treated wood have to be corrosion resistant. You'll find these kind of provisions in 2304. I didn't mention 2303, but in there you'll see all the product standards listed for individual wood products. I mentioned now this in chapter 23, conventional light frame, 2308. This is what we have to be careful about, and you have some limits. This came from prescriptive provisions for 1 and 2 family dwellings many years ago, so it is very limited. What limits the use of this section particularly is 40 pound per square foot floor loads. So be very careful with using 2308. It is useful in some circumstances, but it has limits. And if you're in 2308 for commercial buildings, make sure you're checking those limits back in 2308.2. And finally, in chapter 23, we have a section that references the wood frame construction manual. Even though on the cover of the manual it says for 1 and 2 family dwellings, and that's its primary use. If you have a commercial building that's single story, slab on grade, that's wood frame, and it fits within the scoping of chapter 1 of the wood frame construction manual in terms of size, dimensions, height, and it's not a higher risk category building, this may be a great design tool for you as an engineer or an architect, because this is an engineered document. It's engineered to all the applicable loads per geographic area in the United States. And so there are many tables that do some design for you, and may be a great design tool. All right, I know I went through that very quickly, and believe it or not, we're 40 minutes into our webinar. I'm going to go ahead and go on to heights and areas. I'm sure there are many questions on types of construction and some of the structural provisions, but we're going to go into one of the most useful purposes of the code conforming wood design document. If you have it and have printed it out, if you flip through the back, you'll see some tables for sizing buildings. It's a great tool for that. What's it based on? Let's go through some basics of height and area in the IBC. It's all in chapter 5, which has gone through some new development in the last few years with new tables and so forth. However, the parameters there have not changed very much at all. They will in the 2021 for the new type 4 construction types, but they have not changed much over the years for up through the 2018. You have the basic equation here. This is right out of the code, and you have the variables. What we're looking at here is allowable area per story, right here. This is for single story buildings. We will be pulling from tables in chapter 5. I'll do a quick example. The tabular area per story out of the table, and then it's factored. Multi-story buildings, the final factor here is the number of stories, which you multiply it by 3 if you have a 3-story building and taller. Otherwise, you pull, this is a frontage factor, and this is a allowable area factor right out of the table. Now, what's this thing? I'll talk about this in a moment when we get to the example. But these tables, by the way, are out of the code conforming wood design. I'm not intending to tell you everything about these tables, but they are the kind of tables that you go into in the building code itself in chapter 5. You can use them from chapter 5 or the code conforming wood design as a quick check. And you have heights above grade. So you have the use groups here, heights above grade here in feet. How about stories? Use groups here, heights above grade in stories over here. And then this is the thing that we have to plug into these formulas right away. It stands for non-sprinklered, and this is sprinklered. So this row here, we're gonna use in the formulas. When it comes to R2, you even have it in R2, non-sprinklered, but we know, if you don't know already, that all R's are required to be sprinklered. So what's that row doing there? Well, we use it in the formulas. And then you have the allowable area, similarly based on the occupancy group and the construction type, which construction types are listed up here. You don't see them in this slide. But, so here's another formula you use to determine an increase you get for open frontage around the building. And you've probably done this. Let's go through an example and we'll work out one quick. Okay, school building, group E, type 5B construction, sprinklered. Very simple, straightforward. Maximum allowable building area, what is it? Here's where we go right into 506.2 of the building code. We have to pull this first to fit it into our formulas. We can calculate the frontage calculation like this, and you can go through this step by step later as you watch or look at the CCWD. We also pull from the table the allowable area factor from the table 602. Both this and this come from the same table, table 602. And we plug them in to this. Very simple. So we pulled the non-sprinklered value. We gave it the allowable increase based on what the I sub F was. We did that separately. We got 38,000. We got 40,000 square feet is the allowable area. So that's just review for you. Let me show you a simpler way to do that when we get to the code conforming wood design tables. What we just did was out of the IBC, and by way of caution, remember that you might calculate something out of chapter 5 of the IBC, and chapter 9, which is the fire protection sprinkler chapter, may catch you. In other words, you may be able to calculate a non-sprinklered building area. However, chapter 9 may say you get up to 12,000 square feet, you got to have sprinklers, even for groups M, S, and so forth, not just R. So just be aware that you got to check chapter 9 at all times when you do this, because, and sprinklers, by the way, give you significant increases in building size. This is all done for you in the tables in chapter 5, but when you put sprinklers in a single-story building, you get 3 times the allowable area. In a multi-story building, you get 2 times the allowable area per floor. And there are many other advantages to sprinklers for purposes of design. So you often get to have unprotected corridors. You get some flexibility in means of egress. You get some reduced ratings in some of the building rated element separations and so forth. So there are many trade-offs, you can call them, or some would say trade-ups, because of the vast increase in safety for occupants in sprinklered buildings versus non-sprinklered buildings. Some call them trade-ups, but these are features that change in the code for the building when you put sprinklers in. Very significant in many ways. Now, total building area limit. I mentioned this. It's this factor right here in the equation 5.2 of the code. It works like this. So you calculate the allowable area per story, and in this case, if you had 37,500, and then if you go beyond 3 stories, you've got to split that up. So 37,500 per story times 3, you get a total building area of 112,500, but it's got to be split 4 equal floors. Now you're down to 28,000 per feet. So just remember, allowable area per story times 3 is maximum building story. Building area, rather, not building story. Okay. Maybe this is a gimme if you haven't fallen asleep. Marcy, let's do this one. Let me go ahead and read it. Marcy, we can't hear you if you're there.
You're right. I muted myself.
Okay.
For single occupancy buildings with 4 or more stories, the total allowable building area is 2 times the allowable area per story, or 3 times the allowable area per story, or 4 times, or the number of stories times the allowable area per story. All right, this one is harder because we're a little bit more scattered over the 4 answers.
Yep.
Okay, we've got 45 seconds, so I'm going to go ahead and close and share the answers. All right, we've got evenly split between B and D. So 42% say 3 times the allowable area, and 41% say number of stories times the allowable area. And the real answer is, Paul?
3 times B. Now, I went over that very quickly, and many of you got it right. But just remember, when you get 3 times for the maximum building area, and you have to split that over the 3 over the 4 stories in this case. So good, the question helped us to know what some might be missing. D is not correct because the allowable area per story times number of stories would be times 4, and that formula requires you to limit it to a maximum of 3. So those of you who may have drifted off know what you need to take a look at now. So 3 times the allowable area per story. Let me show you a simpler way. Code conforming wood design document, you have a series of tables in the back. This is one of the most popular features of the code conforming wood design document. So look at this table in the back. They're listed per use group and whether the building is sprinklered or not. In this case, it happens to show, this table shows the non-sprinklered building group E. Number of stories on the left, percent open frontage estimated in this column here, and then just the wood construction types listed here. And you get an allowable area per story given you right out of the table. So not only that, but I'll go back to the table for a minute. So what you're looking at here is the, sorry, I can't find my cursor here. Here it is. What you're looking at here is these figures out of the table are allowable area per story. Okay, it says right up here, per story, not per building, but per story. Okay. Now, I'll just point out that the footnotes to these tables give you the basis of the tables. First of all, when you calculate open frontage, you're going to have it based on a 30 feet or more open frontage width. So it'll be somewhat of an estimate when you use these tables. If you want to nail it down to the exact number, you do have to go through the formulas in the International Building Code. But also, I mentioned Chapter 9. The footnotes tip you off when a Group E, for instance, needs to have sprinklers, even though you could calculate it without sprinklers in Chapter 5. So the tables are also helpful to alert the user to some limitations you may miss. So let's go back to our example. Single story, 5B grade school, 13 compliant system, NFPA 13 compliant automatic sprinkler system. Here's the open perimeter on 2 sides in this example. So the frontage increase is based on having 50% of the open space qualify. And if we go right to the table, so we did that I sub F formula and we got 50% here. We're a single story building. So we enter the table with those 2 and we find out right away, just by a quick look, 40,370 square feet. So it's done the formulas for us. So this is a great tool for taking a quick look, occupancy group, sprinklers or not, number of stories, approximate open frontage, boom, you have allowable area per story. Another example, group I1, 13R sprinkler system, for instance, in a group I1 care facility. You have a table looks just like before. Since it's an I1, you see these kind of figures for type 4B are greatly reduced. Why is that? Well, if we look at the footnotes for the condition 1 or I1, group I1 condition 1 table, it tells us how the allowable area was based. And then it tells us in the footnotes also that, by the way, if you're using a 13R sprinkler system, you don't get an increase due to sprinklers. Okay, so it helps you get to the right answer on this one. So the example, I1 13R system, single story. We enter here 50% open frontage. Well, for this, based on the use group, we only are allowed 5,600 square feet, 20. So this is a great feature of the code conforming wood design. And that alone may be a reason to keep it on your desk. Many people don't know that there's unlimited area wood frame buildings permitted. The key here is single story and sprinklered. These use groups, single story, sprinklered, and 60 feet around the building, fire separation distance, unlimited in area. Many people are surprised by that. You can even have A1s and A2 assembly occupancies in unlimited area buildings, but you got to go to section 50741 to check the limits. There are some specific limits, and it is limited to type 3 or 4 construction. Okay. How about A3 assemblies? Even they can be unlimited in area. There are restrictions. Go to 507.1 for all of them. I think it's single story. Construction types are limited. You've always got the sprinklers. You've always got the fire separation distance, minimum 60 feet. But even A3 and some A4 buildings, even some school buildings can be unlimited in area. So check 507. All the unlimited area buildings are listed in 507. Classrooms in this case have to have 2 means of egress, one directly to the outside to qualify. It's just one of the conditions for Group E unlimited area building. How about unsprinklered? Well, if you're dealing with non-combustible goods, manufacture or storage, only non-combustible, rarely used, but they can be unlimited in area. And then finally, even 2-story BFMS, 2-story even, sprinklered, 60 feet, NFPA 13 system. Whole key here is it's low to the ground, it's got lots of fire separation distance, and it's fully sprinklered. If you don't quite have the 60 feet, you'll find a provision in there to rate this wall for 3 hours, and you can reduce it to 40 feet. So there's a little caveat there, 507.2.1 if you need to use it. And you can always, of course, put in a firewall. This is the big one, has lots of restrictions on openings, highly rated, and restrictions on materials. It's not a fire barrier, not a fire partition. It's 706, all the requirements for a firewall, and you can start your building area over. So put a firewall in and you can keep going with your building if you've reached your limit. Okay. Only in type 5 can they be wood frame. You can have wood frame firewalls, but only in type 5 under the IBC. In type 3 and 4, they have to be non-combustible. So there's no wood frame firewalls, types 3 and 4. You got some categories here for special occupancies that allow you to, in essence, put 2 different buildings together vertically. This is very common use for parking under Section 510 of the code. If you go to 510, you'll find one of the primary sections used is 510.2, which allows you to use a 3-hour rated horizontal assembly between what is typically parking below and a type 1 building, actually type 1A building below, so a concrete parking structure, highly rated, maybe a couple stories of parking, a 3-hour assembly, and apartments on the top. How can we do this? Well, you might have a type 5 or a type 3 building on the top, over top of a 1A. 2 different buildings vertically, but very specific conditions under which you can do this. And one of those conditions is you're never exceeding the height above grade for the building on the top. So in 510.2, which is the most flexible section, a lot of people use it. If you've got a type 3 or type 5 building up here, it cannot exceed above grade in height in feet. You measure from grade, you measure to the bottom of the type 1A building down here. So that's one of the main restrictions. There's also some means of egress provisions that you have to meet in terms of your vertical exit enclosures. Okay, use groups are specified too down there about what you can put in these kind of buildings. And I threw this slide, kept this slide in because this mentions a different section, 510.7. There are several of these sections in the code. They all have their own conditions. This is another one that allows you to have an open parking, maybe in the future, mass timber parking below. You can have a type 1 building below. different section, different conditions. There's a variety of these in section 510, so take a look. New to the special occupancy provisions that are pedestal or podium buildings that I've been talking about here are some new height restrictions for what you have to do with the attic. So if you are over 55 feet above the lowest level of fire department access with a podium building, there's new provisions as of 2018 in 903.3123 for protecting that attic with either sprinklers. Basically what this comes down to in attic of any size is whether you have to sprinkler the attic or not. Those provisions are new. Wanted to limit in height in pedestal and podium buildings. It seemed appropriate. And there have been some significant fires. Seems appropriate to limit when you can have an unsprinklered attic in one of these podium buildings. So these are new. Take a look at those. Of course, the International Building Code allows mixed occupancy buildings. There's some excellent presentations on this, how you calculate the formulas that allows you to mix your occupancies, because so far we've only talked about single occupancy allowable area. But one thing to remember is in 508, you're given a story that that does not have to contribute to the building area or the building height in most cases. You're given a basement. And when you have mixed occupancies, there's three separate approaches. One is you don't provide a fire resistant separation between them, and you base the building height and area on the most restrictive occupancy. And then the second is you do provide a fire resistance rated separation between them, and you have to do a calculation comparing the ratio of actual area to allowable area for each occupancy and add them together, and it comes up to less than 1. There are provisions for this in the building code, of course. So just so you know, there's a way to do it. You can even mix them. Okay. All right. I know I went through that very quickly, and I'm just going to, by way of review, go through quickly the occupancy groups that the code conforming wood design publication covers. And if you're not sure what the occupancy group is, who gets to decide? Well, the code official. And he or she's going to decide that based on classifying the building on what it most nearly resembles. The code says that right away. Of course, the designer has to make the initial determination and then check with the code official to make sure that he or she agrees. These are the ones covered in the code conforming wood design. And these have gone through some changes and nuances. So you have to go back to chapter 3 often to check the actual descriptions. But A1 are the big assembly ones, studios, motion picture theaters. A2 is a catch-all for all restaurants, bars. Now casinos are included, nightclubs, anything that serves food and drink. A3 is a catch-all for only assemblies. Common ones are churches, places of worship. A4, indoor sporting facilities. 5, outdoor. B is a catch-all for whatever doesn't fit in any other use group, usually if it has anything at all to do with business. And by the way, chapter 3 lists examples of each of these use groups. Group E, educational. It also includes some daycare occupancies with restrictions on age and number of hours and so forth. F, factory, industrial. I, institutional. I has undergone some expansion and some redefinition over the years in recent editions of the IBC. In general, still I2 are hospitals and nursing homes. I1 are other kinds of care facilities. I3s are jails. I4s, daycare. You can see how that may be new to you. I1 through 3 are further broken into conditions for the occupant's ability to respond to an emergency. M is mercantile. R1 are hotels, motels, boarding houses. R2 apartments, dormitories, live, work, so forth. R3 single-family dwellings. Why is this in the commercial code? Well, you might have one attached to another commercial building, or you might have an apartment up on the second floor. It might be an R3. Also includes some daycare definitions as well. R4 are residential care and assisted living. Okay. 2 conditions there based on the type of occupants in them and their abilities. Group S storage. Okay, let's do this poll 2 real quickly. I know I went over that very quickly, but Marcy, go ahead.
Sure thing. So which of the following occupancy classifications applies to residential care and assisted living facilities for 6 to 16 clients? Is that I1, I4, R3, R4, or none of the above? All righty. A little bit scattered again. But not too bad. We've got one that's kind of a forerunner, and I've got 30 seconds, so let's close and share. All right, 41% say R4, and then very close tie between I4, R3, and none of the above. So let's find out what's.
It's R4, and R4. You all who caught that with how fast I'm racing through are really sharp, but or you may have just known the answer. Good job. All right, I'm going to wrap up here with other certain building features that can be wood and point you to where you can go in the International Building Code for them. And then the final section will be on precautions during construction. The standard for them. So check out this standard, permanent wood foundations. Interior finish, more common. Wood is very popular interior finish, and it can be used. Really the only code provision here is flame spread classification, depending on where it's used in the building. And we'll talk about that. Well, here it is. This is a modified table out of the code. Flame spread classification for all interior finish depends on the location in the building and the occupancy group. Okay. So type A, interior finish. Type B, this is flame spread, and type C. Type A is most restrictive. Okay. And note when you get to chapter 8, the table is based on sprinklered and non-sprinklered. So in exit elements, more critical, lower flame spread classification. Okay. Same table for sprinklered buildings. Everything shifts. You can have flame spread classification of B or C in most buildings, except for jails. So you can see how important sprinklers are for life safety. If you want to know what the flame spread classification is for any particular wood species, we have another document designed for code acceptance number 1. If the manufacturer of the interior finish doesn't provide it to you and you're using wood finish, you can go find out what the flame spread is from this document. Most classify as B or C, but there's some exceptions. Wood flooring, for instance, does not have to have a flame spread classification. It's got a blanket permission and exposed members of type 4. There is an exception there with the new mass timber construction types and the potential to build exit elements out of mass timber. Those do need to be protected, and you'll see that in the future. Wood trim, very popular. If it is trim and classified as trim rather than being subject to all the requirements for interior finish, it is subject to some of them, simply limited in allowable area of the wall or the ceiling, 10%. And what about windows and doors? Well, you can have wood windows and doors in most construction types. The key here in exterior walls is the fire separation distance. So That's in chapter 6, table 602. And then in 705.8, you've got the restrictions. In summary, if you got 30 feet or more, you're pretty much home free. 20 feet or more if the building's sprinklered, and so forth. As you get closer to the lot line, you get more and more restrictions. Your opening has to actually have a fire protection rating, has to be a tested opening frame and so forth. And then when you get so close to the property line, you can't have any openings at all. The interior doors can always be wood as long as even wood doors can have a fire protection rating, of course. If the door is in a wall that's required to be fire resistance rated, it does have to have a fire protection rating, has to be a listed assembly. So be careful with that. And of course, the code has provisions for wood siding in 1405, and also appendages to the exterior wall. Even in types 1 and 2 construction, you can often have wood balconies. Where do you find those provisions? Well, they used to be in chapter 14. Be careful, they're back in chapter 7 now. They were moved. So you go to 705.231 and you'll find the area limits for having combustible balconies on various construction types. And as a rule of thumb, you're either heavy timber with the floor or you're rating the floor itself. It's a rated floor itself similar to the interior of the structure. The length of these, but you find those parameters now in 705.231. You can have wood stairs on the exterior of a building. This is a common question. If the building is limited in height up to 6 stories, if the building is type 4 or 5 construction, you can have exterior stairs of wood. So check the conditions in these sections. The code has specific requirements for projections and specific to the material, combustible projections. The code conforming wood design document actually has this diagram. So, and this is very complicated. And this is an example of where the code, we have to remember the code is not put together by one individual who's thought everything out. It's put together by committee. So you have some very specific provisions. And when I say by committee, a committee hears an initial code change and then the membership votes on it. The discussion is limited to committee activity and testimony at committee activity. So, you know, we have to remember if these seem complicated, and they are unnecessarily complicated, we're trying to give you direction with this diagram in the code conforming wood design. But just remember, code is a consensus document mostly put together by committee. All right, 2304 has a section on where wood needs to be protected by being treated with either pressure treatment for durability or for fire resistance, and the locations where that's required. So you'll find it in 2304 and also 2303. Separate sections for preservative treatment for durability, protection against moisture, and fire retardant treatment. All right then, finally, precautions during construction. Construction fires can be significant losses. They can be very dangerous, and they can be very hard on downtown communities, even though buildings are not occupied typically. So these can be life safety circumstances and dangers for first responders, for property damage to adjacent buildings. We have a coalition that there is a coalition that we belong to and greatly foster among designers, code officials, organizations to reduce construction fires. And The building code, IBC, and the IFC fire code contain specific provisions for precautions during construction. Here's one, 3314, fire code official, if requires it, fire watch must be provided during non-working hours, even when construction exceeds 40 feet in height above lowest adjacent grade. Okay. Fire watches, by the way, as a topic, are covered extensively in the fire code, especially for hot work. Okay. One of the leading causes of fires at construction sites, cooking in the building under construction. Also hot work, where a fire watch is not provided for the required amount of time after the work is completed, and so forth. Some of the other, of course, fire extinguishers are required, specific placement at certain stages of construction. Maintaining means of egress. This is life safety for the construction workers themselves, very important. It's in there. Construction reaches 40 feet, one permanent stairway that has to be lit, and so forth. Standpipes have to be functional when the building reaches a certain height. So if there is a construction fire, the fire service can use them. Building should never be occupied if there's a required sprinkler system that has not been commissioned and put in service. Goes without saying. The requirements of the IBC and IFC are similar, but keep in mind that the IBC directly references the IFC that says, basically, if you don't find a requirement here for buildings under construction, everything in the IFC also applies. Sometimes these provisions fall through the cracks. It's the owner's responsibility often to make sure that some of these provisions are put into effect. The designer is the agent of the owner, may be involved, and so forth. It's not always just a code official. So keep an eye out for that. I mentioned the fire code, temporary heating equipment, chapter 33, provisions for those, smoking, no smoking. Fire watch, 3304.5. And these were greatly strengthened, by the way, in the upcoming 2021 code, where the contractor will be held responsible for keeping records of inspections by their fire watch personnel that can be inspected by, or that could be looked at by the fire official when he does his or her inspection. Welding operations, there's provisions there about permitting and fire watches. Electrical wiring, of course. Fire prevention superintendent, the owner, I mentioned the owner has responsibility. The owner is required to provide or designate a fire prevention superintendent, a comprehensive program for fire prevention. I think often the best companies, the most responsible, conscientious are doing this, but some are not. So it doesn't matter how good the code is in regard to materials and fire resistance. If it's not followed, it's to no effect. So let's make this put this foremost in our minds. Okay, access by firefighting vehicle access, approved water supply, and requirements for safeguard during roofing operations. All right. So I know I've gone through these things very quickly. We may want to back up. I'd like to have a nice long period of question and answer. I believe this is our last slide. Oh, we have a poll question. Marcy?
Just one last quick one. I'm going to read it here so that you can think about your answer. So if required by the fire code official, that's key, if required by the code official, a fire watch must be provided during non-working hours when construction exceeds 40 feet in height above lowest adjacent grade. Is that true or false? So get your answer and then I'm going to launch it. What do you say, Paul?
It's true. Well done. You all are listening.
Excellent. All right.
Okay, Paul, excellent job as usual. And we had a few questions come in. So we'll start with one regarding primary structural framing, primary versus secondary. Whose responsibility is it to determine which structural framing members are primary versus secondary? Is that the architect or the structural engineer, or?
Okay, that's a great question. And I'll just start by reminding everyone that those terms are defined. If you go to chapter 2, primary structural frame is defined and secondary structural frame are defined. Now, you might not find them right away in the definitions. You have to kind of look under different words like secondary or primary or structural frame. But they are defined. And the provisions for those are found in section 704 and the subsections. So the question often comes up is, when something's a primary structural frame, it has to be individually protected for fire resistance. And that is true. Unfortunately, those sections were not written with light wood construction in mind. However, we have to apply those sections as they may apply to light frame wood construction. So be aware that sections 70, there's provisions in there in 704 that talk about light frame and when the individual protection can be omitted in light frame. There's some conditions, but you have to rely on those definitions. So if you weren't aware the definitions were there, go to the definitions first. And then in terms of interpreting the code for any particular project, of course, buck stops with the code official. The designer has to make the initial determination to be confirmed by the code official. So.
Okay. So another question has to do with percent frontage. Can you maybe explain or define percentage, percent frontage definitions, requirements?
So basically, fire separation distance, you have to have at least 20 feet, and you get, if you have 30 feet, you get a full increase on any particular side. So fire separation distance, again, back to the definitions, that's a defined term. It's from the exterior wall of the building to the lot line. Or if you have two buildings on the same lot, typically it's to an imaginary lot line that you set up in between the two buildings for the purpose of determining required wall ratings for the two individual buildings. That's all defined, or that's all determined in the definition of fire separation distance. So if you have 20 feet or more, you go to that formula, that I sub F formula in chapter 5, based on how much of the perimeter of the building has 20 feet or more. And each term is clearly defined in that formula. Maybe I could flip back to it, but I'm not sure I want to take the time. Probably want to go to more questions. But if you still have questions on that, feel free to email us and we can untangle it a little further for you. But fire separation distance definition, and each of the terms in that equation for I sub F. And I think you'll get it.
Okay, let's see. Question about fire watch. Is that really at the decision of the fire official? Maybe I'll paraphrase and say, is that only at the decision of the fire official?
Yeah, what that's referring to is a new provision in the 2018 code. And the reason we emphasized where required by the fire official is because that's what the new provision actually reads. In your 2018 code book, you go to 3314.1 and you'll see there's a bar beside it. That means it's new or revised. So the key here is this is non-working hours. The code previously did not have any specific provisions for fire watches during non-working hours. It has many provisions already for fire watches for various activities on the construction site, hot work and so forth. But this particular provision is new. It's related to non-working hours, and it is contingent on the fire official requiring it. So it's not always absolutely required. I think it should be always absolutely required, and I hope fire officials do this. But that's why this particular provision is dependent on the fire officials' initiative.
So that there's no current requirement that once you exceed 40 feet, this is a new requirement. This is based on.
Yeah, this is a new requirement for non-working hours. There may be a provision, I'll have to look at that a little more closely, when you exceed 40 feet for a fire watch, a more general fire watch during construction hours.
Okay.
It may be in there, yeah.
Okay. Paul, are you familiar with the terms restrained versus unrestrained buildings? That's a new one to me, but someone's asking how that's differentiated in the codes. It might be specific to a state code. I'm not sure.
No, I think that has to do with the conditions of connection or the conditions for the performance of a beam or a column in terms of how it may perform under fire conditions. If it's restrained, it will perform one way, and unrestrained, it might perform another way. And I think that that's going to be a condition of the testing that's performed on the element. So that has to be something that's specified. Is the beam restrained or unrestrained? This is my understanding, and I'm not great at this, but I think that's going to be a condition of the testing. If it's unrestrained, it does not require certain. It's by its connection would the nature of the connections at each end of the beam is one thing. If it's restrained, the nature of those connections is another thing in terms of expansion, contraction, and so forth. So I think that's what that's referring to, buddy.
Okay.
Okay. I would refer to the test listing data for making a further, for going with, or for, thinking about that topic.
Great. That's a new one for me. So I learned something today too. Great. Table 601 and section 70410 require exterior bearing walls in type 3B construction to be 2-hour rated. If those walls are simply infill and the bearing components are red iron columns, is the wall required to be rated?
The walls always, all right, so this one I'm going to go back to table, oops.
By the way, while you're looking, we've got someone chiming in here saying you were right on with your explanation of restrained. So
oh, good.
You got
thanks for the vote of confidence. Okay, so we're back to type 3, and I wanted to pull this up. I wanted to pull up 601. All right, let me switch here. Computer's being temperamental.
Yeah, that's okay.
All right, non-bearing walls and partitions. Let's see here. We got table 601. Get my pen here. So type 3, infill walls, non-bearing walls and partitions, exterior, table 602. So the rating of a non-bearing exterior wall would only depend on its fire separation distance. That's what this is telling us here. So exterior walls, bearing walls always have to be rated, but non-bearing walls, if they're non-bearing, would not have to be rated unless the fire separation distance required them. That's in table 602, a different table. So, depending on the occupancy group, it could be unrated. Now, Do they have to be non-combustible? Yes. Can they be fire retardant treated wood? Yes, as a substitute for non-combustible. Yeah, that's a good point. Non-bearing walls would not have to be rated often. So,
okay. So you touched on it, but maybe you can elaborate a little bit more. I know we're talking 2018 IBC here, but maybe give us a little more of a sneak peek overview on what's coming in 2021 for new types of construction with respect to tall mass timber buildings.
sure, that's a fun topic. All right, see this column right here. This is going to be split up into 4 columns, actually. Trying to think if I have this handy. What do you think, buddy? Should I try to go to our website? And
we could we can also look for the last webinar that you and Jason did on this topic and chat that out in the chat box for folks to be able to get to that.
I won't fish around with trying to find this on the website. I'll just describe it from here for this group. By the way, if you go to awc.org/tall mass timber, or even if you forget and put tall wood, you'll get to the same place. You'll see the code changes. In the 2021, the ICC Ad Hoc Committee on Tall Wood Buildings finally decided to split this out into 4 construction types: 4A, 4B, 4C, and HT for current heavy timber. You'll see new columns in here, and you'll have A and B and C under type 4. The ratings for A and B and C mostly are 2 hours. For A, it might be 3 hours. It'll be 3 hours. So the ratings will be the same as these for type 4A, same as these for type 4B, and the type 4C will also carry these same ratings in this column here. So remember that picture of cross-laminated timber. The other requirement besides the ratings will be a minimum covering with non-combustible construction, gypsum primarily, up to 2/3 or at least 2/3 of the rating of the element. So this is all new. Now we're going to have heavy timber walls, solid timber floors, for instance, heavy timber columns, and in many cases walls. And they're going to be rated, and they're also going to have a minimum requirement for non-combustible protection, such as by gypsum. And this is the first time that we are going to have building elements that require both a rating as well as a minimum cover by non-combustible protection. And in that way, if you watched any of our new mass timber presentations and the webinars we already have online, you'll see that the goal for fire performance in the new mass timber construction types is to allow a building content fire to burn out without it affecting the structure of the building. So you have in your taller mass timber buildings the potential for a contents fire to start. Let's say the sprinklers don't work and the fire department does not arrive. The goal of the protection provided in the 2021 code is that a content fire can burn out without potential for any structural collapse in that building. That's the assumption pretty much for type 1 now. That will be the assumption for type 4A when it's in the code. So there are many new concepts with mass timber now, and the need for the ad hoc committee was very definite in regard to there wasn't enough space in the current construction type scheme to handle the new structural capacities and fire resistance capacities for mass timber. And so that was all broadened, and It's really genuinely new stuff. Very significant to add new construction types to the code. So be prepared for the ICC/AWC webinars on that topic coming up in the fall and all throughout next year, because they'll be very helpful.
Yeah, and again, some helpful comments coming in here from some other AWC staff members. Just to remind folks that Type 4C does not require gypsum covering. That's a fully exposed heavy timber application, even though it requires the fire rating that you mentioned.
Yeah, that's a good point. 4C is will require 2-hour ratings throughout for exposed timber, but no non-combustible protection. So as you might guess, Type 4C will not be permitted to go any higher above grade than current Type 4 HT as a result. So it's heavy timber. It's like a current heavy timber building, but does not, it can be, so current heavy timber buildings do not require any protection on the elements, any gypsum protection. They perform very well. They're limited to 85 feet above grade for most occupancy groups without protection, and that'll be the same for Type 4C. But the difference with Type 4C is that it will require a rating 2 hours throughout, even though it can all be exposed. So,
excellent. Well, Paul, thank you very much. Again, a great job today, and I think we're gonna call that a wrap.